Good morning, everyone. Today, I would like to share the university and department safety policies for the academic labs. So, I'll take 45 to 1 hour lecture, and then after that, you will be given questions we call scavenger huntings, and you will be given like 3 hours to complete this scavenger hunting. This scavenger hunting contain the questions which is based on the presentations that I am going to cover today. So, the learning outcomes, so by going through this safety PowerPoint, so we are expecting from you to learn about the safety rules, regulations, lab materials, equipment, and then what are the potential hazardous chemicals and how you can work with the material safety data sheets we usually call MSDS, and then symbols of hazardous material, and then how to store the chemicals, and then finally fire safety. Mainly, we are going to discuss the academic lab and then the safe storage of chemicals and then fire safety in the labs. So, going to the academic lab overview, we would like to talk about the general lab rules and then personal hygiene, MSDS, housekeeping, protective clothing and equipment, chemical and physical hazards, ventilations, and finally going to the emergency responses. So you know that we have the several labs in the ground floor, first floor and the second floor. Ground floor we have analytical instrumentation lab. We have the two pilot plant lab we call left and right one pilot plant labs. And then first floor we have the biochemical engineering lab and food engineering lab and computer labs. And the second floor we have energy and environmental laboratory, analytical chemistry laboratory, and then also we have chemical and glass store. So going to the floor plan, so you can see here the ground floor we have analytical instrumentations instrument lab, and then adjacent that is the pilot plant lab A, and then right side is a pilot plant lab B. And the first floor we have the biochemical engineering lab and food engineering lab. They are close together, and then we have the computer labs. And the second floor we have analytical chemistry labs, and then we have energy engineering labs, and also we have the chemical store and glass store which is adjacent to the analytical chemistry labs. You should know these things when you are going to fill out the scavenger hunting. So let's go to the general lab rules, right? So the general lab rules means like things you have to do before you are coming to the labs. You have to dress properly. Don't wear shorts, skirts, pants, and sandals because your body will be exposed into the chemicals. So you want to avoid that one. And if you have the long hair, you can tie it back, and then most of the time what I have seen from undergraduates, they are not reading any procedure for the given day. So please read and understand all the procedure for the given day. Keep that in mind. And you should have to familiar with the standard operating procedure if you are going to handle some chemicals, and then what kind of hazardous symbols are associated with this chemical, what kind of personal protective equipment you should have to wear, and then how to storage those chemicals, how to dispose this waste, and then in case of emergency how you can handle. Keep in mind that all the informations are included in the MSDS. We call the material safety data sheets. So material safety data sheets is just a document which contain the informations of potential hazards like health, fire, reactivity, and environmental hazardous symbols, and then also give some informations about how to work safely inside the lab. So there are two systems, NFPA system and HMIS system. NFPA is a National Fire Protection Associations. So you can see here it's a diamond shapes, and then the blue color responsible for health, and red one is a flammability, and yellow one is a reactivity. For the given chemical, we have these three color, and then we have the different numbers. For the lower number have low weight, and the higher number have the higher weight. For instance, these symbols have the number 4 for the flammability. That means it is extremely flammable. If you have the 0, that will not burn, right? You will have some idea about this one. And the HMIS systems is also similar to that one. It's given the color and the symbols, and also the number display in there, and then also the product identification. That means it indicate the meaning of the number, right, whether it is high flammable or not. But in the previous case it is not, right? So there are two systems. As I told you, the numbers are increasing from 0 to 4. 0 has a low weight and the 4 has a high weight, and you can identify whether they are highly flammable, highly reactive, or highly health hazardous based on the number appeared in the label or MSDS form. So can you identify and match those symbols with the following informations? So I guess you know few of them, right? So skull and crossbone. Somebody, somebody familiar with these symbols? Special army forces have this one, right? So this is like a if we have this kind of symbols, we call it like a toxic symbols, and then you can see some other symbols. So it's just like you are going to take the driving license, and you will have, before you are going to face the exams, you have to learn those symbols, right? Plenty of symbols. But once you got the driving license and you are driving, and then you will see the different symbols in the different places, right? Crosswalking, and then the speed symbols and traffic symbols, this will appear at different uh, places, right? Not all will appear at one time. So similar to the in the while you are working in the lab, you will have to learn about all the symbols, but those symbols will appear at different scenarios. I mean, like depending on the chemicals, right? Depending on the experiments. So let's go to these symbols, and then you can identify explosive and flammable, oxidizes, and then if the gases are under pressure, you will have these symbols, and corrosive symbol, and then the acute toxicity, we have the crossbone, and then if it is environmental hazardous, you will have the tree and fish symbols, and then if it is harmful, you will have these symbols, and if it is severe health hazardous like carcinogenic materials, you will have these symbols. In addition to that, there are some other symbols like radioactive material, biohazardous, and some other stuff, so you need to know. So this is just example for the MSDS for the methanol, and then this gives some most of the informations, and here you can see the number one, the blue color is a number one, that means less health hazardous, there is health hazardous, and then number three is has a high flammability because it is a red one, and then has a zero reactivity. And you can also see some information. So health hazardous is a toxic irritant, or the health hazardous is a very uh, harmful one, and then physical hazardous, they have the high flammability, right? This is extracted from the MSDS from methanol, and then you can see target organs like kidney, liver, eye, and central nervous systems, and then what kind of personal protective equipment you need to wear while you are working, like goggles, gloves, and boots, apron. So you need to wear. So, and also it gives some information about what kind of responses you need to take in case of emergency. So this is a hydrofluoric acid. So I don't know whether you have heard about this hydrofluoric acid. It's a very corrosive material. If one drop of hydrofluoric acid touches your hand, so you will get die within like 5 to 10 minutes. So it's very reactive, and it will react with the calcium in your bone, right? So you can see some images which shows here, and the number 4 is a highly health hazardous. So we can apply calcium gluconate as a gel in case of emergency. The personal hygiene, things you have to do while you are working in the lab. There are many things, like always you need to remove the gloves before you are leaving the lab, because you may get contaminated with some toxic material. So while you are going out to the lab, so you can remove those gloves, because if somebody is not working inside the labs but want to come into the lab and will touch the door handle and then get contaminated with those chemicals. Don't inhale the chemicals uh, by yourself, because there may be some toxic chemical as well. And no food or drink is allowed inside the labs, and application of cosmetic products and using tobacco product is prohibited, and never pipette any chemicals by your mouth. And if you have the long hair, please tie it up because it can catch the fire, and the remove jewelry because it can react with the chemicals. And and then you need to know about the housekeeping. The housekeeping is like how tidy you can keep your lab, right? So in case you need to know the emergency shower and eye wash is where those items are located, because in case of emergency you need to directly go to there. So then there is no barrier to go there. Always all the barriers should be removed and it is clear at all times. So make sure that emergency shower and eye wash is properly working at least for 1 week, because in case of emergency it might not work, right? So these are the two symbols for the emergency eye wash and emergency safety shower. You have to identify those. Emergency eye wash and shower is available in our labs. And then you have to keep all the chemicals in a tidy manner. So inspect broken glassware or leaking containers and make sure that all the glassware and all the chemicals are labeled with full name, and should, if it is possible, please put the hazardous symbols, because without the labels it's very dangerous, because somebody coming from outside to inside to the lab, they don't know whether it is a water or it is a hydrofluoric acid, right? In case if somebody think that is water for the hydrofluoric acid, that is, right? So what kind of things can be happen? Store chemical, like hazardous chemical in the secondary containment, and also chemical must be put back to their proper storage location after the experiments, right, after the end of the day, because you have to label these chemicals, and otherwise the technical officers will consider this one as a waste, and even it is dangerous for them as because they don't know what kind of chemicals are inside there. Please make sure to label all the chemicals you use during the experiment, right? And broken glassware you need to put into the broken glassware container. Unfortunately we don't have this one right moment. We are going to buy this one in the future, and then we will keep inside that one inside the lab. Personal protective equipment. What are the personal protective equipment you have to wear during your experiments, right? So if you have the long pants and long sleeve shirts should be worn at every times, and you can use the aprons, right? Apron is the best because we want to protect you from any chemical splash into your body. And refer MSDS before coming to the lab, because depending on the chemicals you have to wear different personal protective equipment and even the apron. So we have the different aprons: full length rubber apron, neoprene or plastic apron we have. So we want to avoid the risk of splashing any chemical to your body. So personal protective equipment and the gloves, right? You have to wear different gloves that will be appropriate for the in a different scenarios, working with different conditions. So heat resistant gloves is used to handle the hot items, and then chiroprotective gloves, which is used to handle the liquid nitrogen, and then chemical resistant gloves you can use depending on the chemicals you are going to use. And then please understand the limitation of gloves. You can use the gloves, disposable gloves, at least for 3-4 days, but don't use more than that. So just remove those gloves, and it is recommended, and it's the best things to do. And goggles, you have to wear the goggles all the times. Don't wear goggles on the forehead, because we want to protect your eyes, right? So in one time I can remember that I was in undergraduates, and then I touched with the chemicals by lid, and then the lid was not tightened enough, and then it was fallen down into the ground, and then chemical was splashed into my eye. It's like a mercurous chloride, very toxic, and then fortunately it didn't burn my eyelid, it just touch with my eye, and I just wash my eye with plenty of water. So I don't want to happen that one into you. So that's why always I am recommended you to wear goggles even if you are not doing any experiments. To summarize the things, we have added some videos so you can see and check those videos. I have uploaded this one in the fields. To move into the chemical hazards are falling into the four main categories like flammable, corrosive, and reactive chemicals, and health hazards. There are plenty of symbols you have to learn. I will go through main symbols, right? So the flammable ones. So flammable are color coded in red. So you can easily identify these symbols. So you can see here. This is the flammable symbol, right? Whenever you see this flammable symbols in the chemicals, you can easily identify, right? Flammable can be self-reactive or pyropotic, like a sodium, potassium kind of material. It can be a gases, right? It can be organic peroxides. So you need to be very careful about these items. And it is recommended to use the hot water bath rather than open flame because it have a high chance of catching fire. So, and the next one is a corrosive material. So this corrosive or irritate means it can burn your like your body, right? Organic tissues like skin, eye, lungs, and stomach. If the chemical is spilled into your hand, it can burn, right? That's why we call the materials are corrosives, and you can identify those symbols. There are a few more things I need to share with you about the handling of chemical. Never pour water into the acids. So because acid can splash into your eye, so add acid slowly, drop by drop into the water, and then open bottles of acid slowly and carefully. Wear personal protective equipment like gloves, goggles, aprons in case of splashes. Conduct all works in all concentrated acids and base experiments in chemical fume hoods. Make sure to check the location of eye wash and shower in advance to start the experiments. Our next one is a chemical hazards like health hazards, right? The health hazards are color coded with blue. So we will have those chemicals, we will have short-term health effect or long-term health effect. Short-term one we call acute one, and the long-term one we call chronic one. So this include like carcinogenic material, mutagens, poisons, and biohazards. Biohazards we call the infectious agents like the coronavirus, these viruses, bacteria, these kind of things we call the biohazards. You can easily identify those biohazards with blue color. Uh, the health hazards, you can most of the time you can see those symbols like acute toxic. That means like it can be fatal. We have the crossbone, skull and crossbone. I have already explained this one. And then for the carcinogenic material, carcinogenic material is like a cancer hazardous material. So you can have this kind of symbols you can see from some bottles. And then biohazardous, most of the time most of the lab working with virus and bacteria, they have post this symbol on the door. So you need to be very careful about these symbols, biohazardous symbols. And then irritant, these are the kind of health hazardous. And then I don't know whether you have born at that time, this guy Shoko Hasahara from Japan. He produced this gas, phosphine gas, very toxic, and then thousands of people were get killed by using this gas around like 1995, I guess. To summarize the things we have covered so far, I have added some video, hazardous symbol video. I have uploaded into the fields, so you can refer those videos in fields. Going to the physical hazardous. Physical hazardous is same like a chemical hazardous, but these kind of things uh, include like machine gardening and compressed gases, electrical equipment, laser, thermal hazardous, and radiation equipment. And physical hazardous, just like we have this physical hazardous like a machine gardening to protect you and all the people are working inside the lab or in any industry or wherever, right? Not to protect the machines but to protect you. So these things that there are some pinch point, so it can have some damage to the people who are working with this physical hazardous, so need to be very careful about preventing injuries. So never shortcut, because shortcuts even can kill you, because the safety things have been added to the machines to protect you, right? So if you, in case if you make a shortcut, so that can be even pay for your life as well. Thermal hazards, right? Thermal hazard, I think most of you have familiar, because you have started with research and you can see this hot and cold objects. We have this thermal hazards. Most of the students think that the hot items are uh, only will have some injuries to the our hands or our body, but keep in mind the cold items also have some kind of effect, some kind of injuries to the body as well. So when you are handling hot items, use heat resistant gloves, uh, and also when you are heating on hot place, take precautions, and then never leave hot plate unattended. That means if you are planning to do some research and then using hot plate around like higher temperature like 70, 80 or 90, uh, have some plan, right? So don't keep switch on the sun for the 24 hours, because we are going to close the lab around like 4:35 and then nobody was in here, and in case of emergency, who knows, right? If something happened, so then that can be a big issue, right? So please be responsible and inform and have some plan. It's better if you can switch off the hot plate around like 4:30 or 5. And if you have, I think most of them have family with these kind of symbols, burn hazardous. Like if you have hot surface, and it means that you don't need to touch these surfaces because it's always hot. So right, so you may have seen those symbols in our hot plates, and you can you can be very careful about handling those items. You have to wear the gloves, thermal hazardous gloves. And the ventilation, so we have one fume hood in the analytical chemistry lab, so you can go there and see it, and then how it is working. So why always we are recommended to use uh, the this fume hood, because you know that you can see airflow, right? Airflow is going from these directions, right? Airflow is going from these directions. Since air is sucked from this direction, the into the outside, right? All the gases or whatever produced inside the fume hoods will be gone to the outside, right? It will not come to the inside to the classroom. So then it is safe. Imagine if toxic gases is produced, so it will never come to the outside, right? Due to the airflow, this will bring all the air and sucked into the outside. uh, that's why we are always recommended you to use the fume hood for any kind of reactions. So make sure that fume hood is working. If it is not working, then the gases will lead to the outer environment, so that will be affected. When you are using fume hoods, make sure not to store many chemicals inside the fume hood. So keeping many chemicals inside the fume hoods, there's a greater chance of escaping those chemicals into the lab environment. So that might be a toxic in case. And also make sure to close the chemicals inside the fume hood. Let's look at about the emergency responses and first aid kit for the following slides. In case of emergency like a fire, so if your clothing catch fire, so it's better to drop and roll, back and roll, because if you run, so then the fire will increase, right? Make sure to drop and back and roll, so in order to disconnect the oxygens and the combustible material. So fire extinguishers are located, you can see in our building we have many fire extinguishers in many places. You can notify where you can identify where these fire extinguishers are located. And fire blankets, unfortunately we can use, unfortunately we don't have this fire blanket. We have the safety shower, so that's why I told at the beginning we can use this safety shower in case of emergency like a fire. So that's why the pathway is clear to reach that safety shower, and then safety shower should be working properly. In case of burns, so like your fingers, your body, or where whatever the place, so immerse this burn area under cold running water as soon as possible, at least for 10-15 minutes. So after that, so notify your supervisor. In worst case, so you can seek the medical attention immediately. In case of chemical spill on your clothing, so what you can do is, so you can before going to the safety shower, you have to remove the contaminated clothing first, and then go to the safety shower and stay there and pull the lever, and there are plenty of water that will wash away any chemical remaining on your body or clothes, right? So notify your supervisor, and in worst case you can have the immediate attention from medical advisor. In case of chemical splashes into your eye, right? So many chemicals are toxic, and if it is splash in your eye, so again you have to wash, you have to go to the eye wash stations and flush your eye with water for at least 15 minutes. Hold your lid open to allow the water to reach all surface of your eye and eyelids. So uh, seek the medical attention immediately, because the eye is very sensitive to many chemicals, and the chemicals can irritate your eye. Even it is not visible at the first place, but after few hours the symptoms will be observed. So that's why I'm always telling you to have the medical attentions in case of splashing chemical into the eye. And there are some other things, other emergency responses. Call the number displayed in the door in case of emergency, in case of danger, and then move away from the site of the hazardous to the safe locations, and then follow the instructions of instructions from emergency personnel, like a safety instructor. You can call him, and you can call head of the department, or you can call me and ask any questions at any time in case of emergency. So alert others to stay away from that dangerous area, because some people in our countries like to gather into the dangerous area, but always it is recommended to keep away from that area. Notify emergency personnel in case of fire, right? Firefighters, you can we have put the numbers, and you can call directly to the firefighters, and they will come quickly to the this fire place. And moving to the safe storage of chemical in the labs. So main thing is a labeling. Principle of safe storage, the main thing is labeling, because all chemical containers must be properly labeled, right? Otherwise it will be big issues, because if we don't have the label, then we don't know what is that chemical is, right? So we don't have the money to say, identify those chemicals, and if the label is missing, so then we have huge trouble. So that's why always we are asking you to keep the label of that chemicals, and then if you can put the hazardous symbols into that label as well, and store those chemical in the proper place. if you see some label is going to be missing, like detached from the bottle, so please paste it using a proper way, because if the label is missing, we have so many chemicals inside the lab, so it is useless and it cannot be used for the current experiment, even for the future experiment. There are main safety things to do. Minimize the quantities. So whenever you are using the chemical reactions, so minimize the quantities for the first place if you are doing some experiment, and maintain the good housekeeping. I have already provided you some guidance to keep housekeeping, and don't stock chemical under the sink. And moving to the fire safety in the labs. So there are 4 classes of fire. We can categorize into class A, B, C, and D. So class A fire is generated from wood, paper, cloth, rubber, and some plastic like ordinary combustible material. Class B is generated from kerosene, paint, thinner, and propane and this organic solvent. Class C is generated from the electrical appliances, and class D is from the metal combustible metal material like magnesium, sodium, potassium, titanium, right? So you need to know that whenever you have these fire extinguishers, please check whether they are class A, B, or C, or D, because so we cannot use class A fire extinguishers to put off the fire generated from class C. So that is the main thing, because electrical appliances generated fire we cannot put off by using class A fire, because it will spread more, right? So most of the labs we have class D fire, class A and D fire, because class D fire can be used for to put off class A, B, C fire generated, right? So these are the main thing you need to know. And whenever you are using fire extinguishers, make sure to use the pass method. Pass means pull the pin, aim at the base of the fire, squeeze the top handle or lever, and sweep from side to side. So you need to have some basic skills to operate these fire extinguishers. And fighting with fires, that is depend, right? So always you should be certain that you have the capacity to put off the fire. If you feel that you cannot do that one, you cannot handle that one, then let the people who have more familiar to put off the fire to work with that fire, right? So uh, don't take any risk if you cannot assist. If you can assist, you can assist, but make sure whether it is possible to assist, right? So activate the built-in fire alarm system. So here we don't have the fire alarm system, but usually United States and some other countries they have fire alarm system. So then once we pull the fire alarm, so everybody knows that there is a fire going on, and then they can evacuate and notify the responsible persons in the department in case of fire. Um, and if the fire is small, you can try to extinguish the fire using these fire extinguishers. And the buddy systems. Buddy system is mainly very useful because it is not allowed to work inside the lab alone. In case of emergency, imagine you face to some accidents and no one is there, and then following day you get unconscious or you get died. Nobody knows, right? So it is better to have the buddy system. So it is always recommended never work alone inside the lab. Door placard and chemical inventories, right? This is the main things. Most of the labs we can see that uh, door placard. This provides most of the emergency informations and emergency personal's informations, phone numbers, everything, and also what kind of equipment, what kind of personal protective equipment you need to wear if you are entering into that lab, and then what kind of chemicals are inside there, whether they are hazardous, whether they are flammable, whether they are biohazardous. Likewise, those informations are given, so need to be very stick into the those informations. So one time I can tell you that I use this credit card. I am using credit card in while I am working in the lab. So I went to the NMR machines. There is a high magnetic power, and then the person who is working there told me that don't bring the credit card because the magnetic power will have some issue for the credit card. Unfortunately, once I go to the go to pay for supermarket, so it is not working. So I told that it was working in the early morning. So they told no, not this is not working because during that time period I have entered into this NMR lab, so then my credit card was destroyed due to this magnetic power. So emergency contact numbers are displayed on the door. So that's what we are planning to do. Actually, Dr. Manipur is responsible for this one. So we will try to finish this putting this informations, the instrumentations, informations, and emergency call list, placards just on the door. Uh, we we have ready everything, and then we will try to do this in our best in the within next 2-3 weeks. So in case of emergency, you can contact for the following issues like chemical exposure and biological releases, chemical reactions or lab spills, any chemical and any natural gas odors, and lab safety issues, personal protective equipment issues, material safety datasheet issues, and lab equipment specifications, design, or whatever thing you can call and ask from any staff members in the department. So little knowledge can save your life. So it is always recommended that knowing little things is not good, but in case of handling chemicals, knowing little things will save your life, right? So accident can be easily avoided if you read the material safety data sheets, and then if you are familiar with the chemicals, and if you take the precautions. So that is the main thing. As I explained you, take serious about these things before you are coming into the lab. So there are some videos I have put into the fields, 3 videos, right? So you can watch and you can have some idea, and then there are plenty of the videos you can see comprehensive details you can grab from those videos. It is available in the YouTube. So please go through this one for the proper dress, lab behavior, chemical hazards, safe chemical handling, and other general hazards. You can go through those websites, refer. And I would like to thank at this moment for the staff members for their great support and guidance, Dr. Anushka and Dr. Kalpage, and our safety officer Dr. Manipura and Dr. Professor Karunaran, and some other technical officers and staff members. They support me very well to establish this safety presentations and also safety environment inside our chemical and process engineering department. So any questions you can ask from me. So I have uploaded MSDS into the field, so you can refer that one, and also you can call me or shoot me an email, and then I will refer those in questions, and I will try to provide answer in as soon as possible. Okay. Thank you.